My name is Bharat Rameshwar Gawande. Today I delivered a seminar reports on Bragg's law of X-ray diffraction. Bragg's law gives the angles for coherent and incoherent scattering from a crystal lattice. When X-rays are incident on an atom, they make the electronic cloud move as does any electromagnetic wave. The movement of these charges radiates waves with the same frequency. This phenomenon is known as relay scattering or elastic scattering. This figure shows that the diffraction pattern of Bragg's law. Now, a similar process occurs upon scattering neutron waves from the nuclei. These re-emitted wave fields interfere with each other either constructively or destructively, producing a diffraction pattern on a detector or film. The resulting wave interference pattern is the basis of diffraction analysis. This analysis is called as Bragg's diffraction. Now, this figure shows that the determination of lattice parameter of the crystals by Bragg's law. Now, Bragg's diffraction, also referred to as the Bragg's formulation of X-ray diffraction, was first proposed by William Lawrence Bragg and William Henry Bragg in 1913 in response to their discovery that crystalline solid produces surprising pattern of reflected X-rays. The concept of Bragg's diffraction applies equally to neutron diffraction and electron diffraction process. Now consider a set of parallel planes at a crystal having interplanar spacing d as shown in figure. Let a narrow monochromatic beam of X-ray of wavelength lambda fall upon these parallel planes at an angle theta. The atomic planes are considered to be semi-transparent. So X-ray reflected from different atomic planes and produces a path difference between the rays reflected from the different planes. The two reflected rays reinforced each other only when the path difference is equal to integral multiple of the wavelength. In the figure, the path difference between rays reflected from the first and second place is given by Fg plus Gh. So, X-ray reflected from the different atomic planes and produces a path difference between the rays reflected from different planes. The two reflected rays reinforce each other only when the path difference is equal to integral multiple of the wavelength. In the figure, the path difference between rays reflected from the first and second plane is Fg plus Gh. Now, in triangle OFG, sin theta is equal to Fg upon Og. Therefore, Fg is equal to Og sin theta and Fg is equal to d sin theta. Similarly, in triangle OHG, Gh is equal to OH sin theta and also is equal to d sin theta. Therefore, the path difference between Fg plus Gs is equal to 2d sin theta. So, for reinforcement, constructive interference is 2d sin theta is equal to n lambda. So, Bragg's law gives equation n lambda is equal to 2d sin theta, where n is an integer, lambda is a wavelength for incident wave, d is the space between planes in atomic lattice, and theta be the angle between incident rays and the scattering plane. Thank you.